polynomial functions. And what I'm going to look at here with you guys real quick is we've actually did a little bit of this modeling of the cubic stuff when we were in polynomials. It's just going to be real fast. When we're working with cubic functions, we're going to work with their intercepts. Same thing you did with the intercept form with quadratics. You're looking for the zeros. So if they give you zeros, you'll be able to figure out your terms. The only other thing here is that in order to write out the equation in that format, is you're going to have to identify the a value. So you'll have 3 intercepts and a point. What do you think you're going to have to do?
Are we going to have to fill things in?
You're probably going to have to do some substitution.
That's crazy.
I know, I have high expectations.
You do?
So you'll be given something like this, or sets of ordered pairs. So the difficult part here is going to be having to identify your zeros. Take a long, hard look and see if you can identify them.
I don't know. This is kind of hard.
So we have -1, -3, and +3.
Nice.
Which means my terms will be
X plus 1, X plus 3, and X minus 3.
Whoa.
with an A and a Y. Remember, f of x and y are synonymous with one another. So now, the other point that I had on there is at...
Wait, one of them be a 2?
2, no.
Where's the one that's... Where's the one that, like, intercepts, like...
That was awesome. I'm sorry, baby, that was priceless. No, babe, we're just looking at the zeros here, bud.
Yeah, is that a 2 though?
No, what?
1.
For the combined. I thought that one was the 0.
Alright, anyway, so what's this ordered pair here? So what do you think are going to use that -2 and 1?
For X and Y.
Yeah. Substitute it. So you know that 1's going to have to equal A times -2 plus 1, -2 plus 3, and -2 minus 3. My suggestion is to not to try to do that in your head because you'll probably get it wrong. No offense.
Why
But
not?
just put in those 3 parentheses that set up like that in your calculator. You just hit enter. It's just as quick.
What is it?
4, -5.
No, it's just 5.
5.
It's like negative, like 8. It's positive 5, right?
No.
Right.
Okay, so this is a lot more difficult than it looks.
Positive 5.
Positive.
Positive 5.
So what is it?
5.
5.
Oh, no.
So 1 equals 5A, so A is 1/5. So now again, your final answer then would be to rewrite that with your intercepts. So Y would equal 1/5 x plus 1, x plus 3, x minus 3. Okay? Extraordinarily simple.
Until.
When you have to use one that you don't know points when you're given tables.
Oh.
So there's a little trick to this. So this is the new stuff.
All I heard was table. Oh, table.
This is a little bit different. We have not done this before. You have not seen this before. When you're given a table, we talked about this earlier in the year where we could try to figure out if it was a cubic, a quartic, a quadratic, by counting the at most changes of direction. That's not always the most convenient way of doing things. It's not always correct. So what we can do is find what are called the finite differences. It's just subtraction a couple of times. Here's what happens. What you're given here is going to be a set of 6 values. 1, 2, 3, 4, 5, 6. And then this is f of x. So this is f of 1, f of 2, f of 3, 4, 5, and 6 respectively. That's all that means. So here's what we do. We list out these f of x values. 1, 3, 3, 5, 15, and 39. And we're going to find the differences between each of those sets, going right to left, right to left, right to left. and we write it below.
Right to left.
What's 3 minus negative 1?
4.
What's 3 minus 3?
0, 2,
2, 10, 14, 24.
Wait, Sarah's still writing when you said, why do we subtract?
This is called finding the difference. We're finding the finite differences. What happens here is that as soon as they have a common difference, then you're able to tell what the degree of the function is. What the power is for the leading term.
Oh, you keep on going?
Yeah, so they're all the same. Yeah,
Is your the difference absolute value or is it?
it's true difference. It's because it can be negative as well. Because it's fine. So, but you wind up with -3 minus -1, you get -4. No, you get -2. But yes. So here, what's 0 minus 4?
Negative.
Negative 4.
Are we okay with that?
Doesn't it take forever?
It's not that bad.
6.
Oh.
Wow.
Wow.
6, 6, 6. Illuminati confirmed. That is Illuminati right here. This is true Illuminati.
Oh, wait. It's crazy.
Yeah, exactly. Illuminati confirmed.
Basically, what happens here is
Math is Illuminati.
this means that this was your first difference, second difference, third difference. So this means it's a third degree polynomial.
So you count the number of arrows?
Well, yeah, because this is your starting point. Because this is just this column here. So how many times did you subtract? 1, 2, 3. That means you have a third degree polynomial. So now to write out the polynomial, you just go to your calculator, go to your lists. Remember how we did our list function? So if you go back to your calculator now and go to your stat, I want you to edit your list. L1 is just going to be your x, 1 through 6. When you say that, I want to start singing Wooly Wooly. Uno, dos, tres, cuatro. No?
Actually, if you sing a little more, maybe.
Wooly Wooly. Wooly
Okay, so
Wooly.
really put the income.
That's
Oh, so you just go with the chart?
Yep. Because what's happening here is you know that negative, it goes -1, 3, 3, 5, 15, and 39.
Third degree is cubic, right?
Correct. So now, when you go back to your stat to calculate, you're going to be able to calculate what the coefficients are going to wind up being. This is, by doing this little finite differences, will allow you to be able to identify whether it's going to wind up being quadratic, cubic, or quartic. What is quartic?
4.
4. Okay. I don't think we had anything larger than that in calculator. Yes, ma'am.
So when we're trying to find out what degree it is, do you just keep going through all the numbers are the same?
Yep. And be careful, if you go all the way through it and you run out of numbers, that means you've done screwed up somewhere. Okay? And those are your, that's your A, B, and C for your,
Why is there a D?
because there's always a constant at the end. Think of a quadratic, your quadratic's in A, B, and C is the constant. When it's a cubic, you've got A, B, C, and then D is your constant. If it was a quartic, you'd have A, B, C, D, E is your constant. Means you have 5 terms.
Does that ever go down?
And then you can have a 27th degree polynomial. Or 25th degree, thank you. Then they just start writing them here. Yes, ma'am. And you count, hey, once again, guys, in order to tell, because this is where you'll forget, in order to tell if it's going to be cubic, quartic, quadratic, count the number of times you had to subtract.
Why do we do that?
Is that how it works?
Why?
Because there's, within the sets of data, there are certain values that occur.
But now I'm never gonna do the overdose.
Right, because this is more accurate.
So why don't we just do this?
I didn't realize we were going to do this later on, so otherwise I would show you. No big deal.
It's so crazy.
Want to do one more?
Alright,
Yeah.
So we have 1, 2, 3, 4, 5, 6. Our f of x values are 6, 15, 22, 21, 6, and negative 29.
You should have X's on.
Yeah. Because there has to be a consistent setup to make this work. 9, 7, negative 1. Is that right? I think so.
Wait.
Hope so.
No. Yes.
Yeah. No. It's negative 35.
Negative 29 minus 2.
Thank you.
And I don't even know how you got 25 in the first place.
Dang.
It's 29 minus 6. Alright, class.
All under.
Like crazy just went up.
That's exactly what I would do. So that was the first time we subtracted. Let's go again. You get negative 2, negative 8.
I don't have any.
Hey, Illuminati confused again.
We okay on that?
Yeah.
I don't waste time.
Guys, negative.
Why are they negative?
Yes, they are.
What question?
Hey, look at that.
This is different.
I don't know. How many times did I have to subtract? 3.
What if you had to subtract 6 times?
No, I mean, not necessarily. There's going to be quadratics. Which quadratics?
Will there ever be linear?
And then there are 2
If it was linear, then you also would have common interest in all of them, wouldn't it? Because then you'd have slope.
So it should
Think
be.
about it, would then
to
your
start
risk
with.
be common? Yeah, because that's, you would identify right away, because your common value would then be, it was just 2 of each of those here. That's how that works, it's a great question. Okay? Yes, ma'am?
How do you decide, like, when you're going down up the arrows if it's negative or positive?
I'm just moving 7 minus 9, negative 1 minus 7. I'm always going right to left. Subtract 1 from right to left. Okay? Homework. So this is section, what is it, 6.9? I don't remember the page number, but I wrote it down back here, so I would have to walk. 384. Locally. We'll do some of the word problem stuff tomorrow real quick.
So I should know. So I should know what this thing is.
No.
So,